honest, on Monday, I think some of this stuff we have forgotten. Actually, I know we have. Okay, I know that happens. So, we are going to go over everything that we've learned in this unit really quickly, and hopefully it comes back to you pretty quickly. And anything you write down in your notes, you can use on the test. Okay, so if you write it down, you get to use it on the test. Is that going to be helpful? I would think so. Okay, so again, if you write it down, you get to use it. So here is the first thing, one of the first things we covered in this unit, integer or negative exponents. So write this in your notes. Integer or negative exponents. And I'll give you a second to write. So jot this down first. Okay. If on your test I ask you to evaluate an integer exponent or figure out what it equals, remember, negative exponents become fractions. Okay, so when you see these problems, it's going to become a fraction. So when you see 7 to the negative second power, it's going to become 1 over 7 to the second power. Right? We want to get rid of that negative exponent, so we make it a fraction. Okay, and then we can figure out what that equals. That's 1 over 49. Do you remember doing that? Hopefully that's kind of coming back to you. Okay, you might have forgotten already. So let's do the next one. 5 to the negative third power is 1 over 5 to the third power. Okay, so you always make it a fraction. And then we figure out 5 to the third power is 125. So it's 1 over 125. There's your answer. Okay, I want you to do this one and type it in the chat. Let's go 8 to the negative third power. What would that be? Eight to the negative third power would be what? And type your answer in the chat. Okay, remember it has to be a fraction. Okay, so this becomes 1 over 8 to the third power, 1 over 512. There's your answer. Okay, so you have 3 good examples in your notes that might help you on the test. So hopefully you have that written down. Okay, here's the next thing we learned in this unit. We talked about properties of exponents. Okay, we're going to go through these one at a time, and we had 3 properties. Here's the first one. Okay, I'll give you a moment to write. Okay, properties of exponents. So we had, when you multiply exponents, if you have x to the a power times x to the b power, you get x to the a plus b power. So you're going to add the exponents together. Okay, so you're adding the exponents. And we'll do a couple of examples to help you out. Okay, now remember, this only works if they have the same base. So the problem might look like this. 2 to the third power times 2 to the fifth power. Okay, and I'm not going to ask you to evaluate it. I'm just going to ask you to write it as 1 power. So that means I need to add the exponents. So it's 2 to the 8th power. Okay. What if I had given you x to the negative third power times x to the 7th power? What would that be? Okay, good. And a few of you got it right. That is x to the 4th power. You're adding the exponents. Okay, so that was one property. Hopefully you have that written down. Here's another one. We had dividing exponents. So if you have x to the a power over x to the b power, here's where we subtract the exponents. Becomes x to the a minus b. Okay. I'll give you a minute to finish writing that, and then we'll do a couple examples. You guys, the whole point of this is to have all of it in your notes in one nice spot so you're not searching all over the place on the day of the test. Okay. So you might see a problem that looks like this. 7 to the 6th power over 7 to the 4th power. Okay, as long as they're the same base, we can do this, and you would just subtract the exponents. So it would be 7 to the 2nd power. 6 minus 4 is 2. Okay. Remember that if they're different bases, if I have x to the 5th power over y to the 7th power, if the bases are not the same, then you would say cannot combine. Okay, because they have to be the same base. Okay, so if we're dividing, we subtract. If you're dividing exponents, you subtract. Okay, and if we have a power to a power, x to the a power to the b power, that's x to the a times b. Okay, so this would be a problem that might look like this. 6 to the 3rd power to the negative 5th power. If it's written like that, you are going to multiply your exponents. So this would become 6. My writing went all over. 6 to the negative 15th power. Because you're multiplying these two numbers. 3 times negative 5 is negative 15. Okay. Another example might be y to the 3rd power to the 9th power. Okay, that would be y to the 27th power, because 3 times 9 is 27. Okay.
Will we be able to use our calculators on the test?
Yes, you will be able to use your calculator on the test, absolutely. Okay. Remember on these though, I don't want you to evaluate them, I just want you to write them as 1 power. Okay. The other thing that we have to remember, that I kind of forgot to put on here, is anything to the 0 power. Zero power. What is 0 power? Anything to the 0 power equals 1. Okay? So if you see something to the 0 power, it equals 1. It can be -7 to the 0 power. It's going to equal 1. It can be 596 to the 0 power. It equals 1. So that's just a good reminder. Anything to the 0 power equals 1. Okay? Are we okay with the properties? How many of you are like, oh, good thing we're going over this. I forgot some of these things. Some of you did, okay? So it's a good thing. All right, here's the next thing we talked about. Scientific notation. Okay? And you're going to have to be able to convert between standard form, where it's written with all the zeros, and scientific notation, where we have a base number times a power of 10. Okay, I'm going to give you a minute to I'll give you 2 minutes to write this down. This might take a little bit longer to write. So I'll give you 2 minutes here. Okay, so again, you should be writing these things down, you guys. Okay, so here's some examples you might want to write down. Standard form means we have all the zeros. Yes, the test is next week. It's on Monday. Okay? So standard form would look like this. 14 million. Okay, that's standard form. We've got all the zeros. If I want to write that in scientific notation, I need a base times 10 to some power. So I need to be able to fill that in. Now we can't forget that the base has to be greater than or equal to 1, but less than 10. So this is where the decimal is currently at the end and I need to move it. Where should I move the decimal to? Where should I put that decimal? Anybody? Okay, and somebody said after the 1. Absolutely. We would put it right there. So it becomes 1.4. Remember that base number has to be greater than or equal to 1, but less than 10. Okay? And then the exponent, you count how many places you moved the decimal. We moved the decimal 1, 2, 3, 4, 5, 6, 7 places. Okay, it's negative if we started as a small number. It's positive if you started as a big number. So this would be 1.4 times 10 to the 7th power. Let me try that again. 1.4 times 10 to the 7th power in scientific notation. Okay, we could have a problem that looks like this. 0.0000562. Okay, and if I want that standard notation, it has all the zeros. And if I want to write that in scientific notation, I need to have a base times 10 to some power. So I'm going to move my decimal. The decimal has to go right after the 5. So it's going to be 5.62. Okay, because we need a number greater than or equal to 1, but less than 10. And then I count 1, 2, 3, 4, 5 places. But because it started as a small number, it's going to be negative. So it's going to be 5.62 times 10 to the negative 5th power. Okay, so hopefully that helped you recall that scientific notation stuff. Okay, and then the last thing we covered was squares and square roots. Okay, you can use your calculator for these things. Remember 12 squared, that just means do 12 times 12. So it's 144. Okay, if I ask you to do square roots, I'm going to ask you to find the 2 square roots. And remember, you can use your calculator, but your calculator is only going to give you the positive answer. So the square root of 49 is 7 and negative 7. It's both 7 and negative 7. Okay, and the square root of 225 would be 15 and negative 15. So don't forget, when I ask you to give me both, that there's a positive and a negative. Okay, questions there?